Hello folks, welcome to the 31st of March. This is day 5. Congratulations for those of you that have followed along so far. Let's keep going. Okay, so our first question uses the word truncated or truncation. Truncated is a special type of rounding, and it's one that we've probably not mentioned that much, but it just means to cut the number short. So for an example, if I was to take the number like 31.3 and I said truncate that to the whole number, I would just cut the number there and say this is 31. I wouldn't think about rounding up or down, I just cut it there. So when we talk about numbers that could truncate to 0.94, it would be anything that starts with 0.94 and then has some nonsense after it. So like all of these numbers would truncate to 0.94 because you just cut the number there. So bearing that in mind, this is slightly different from bounds. In that you're not going to be saying that, half add take away. We're just going to be saying, well, all the numbers, anything from 0.94 itself, because anything that starts with 0.93 obviously won't work. And the biggest number it could be is anything that's less than 0.95. So 0.949999 essentially would work. So your inequality looks something like that. Okay. Next up, we've got some fraction multiplication. You may laugh at this one, but it is something that will be asked towards the start of a paper, and you want to make sure you get full marks on it. So, steps as far as this go: convert to improper fractions, then multiply the top and the bottom together. I mean, we look at diagonals to see if we can cancel anything out first, but we can't. And then convert that back to a whole number. So you want to see how many 128s go into 121, I guess. It doesn't feel like it's going to be any easier to do a bus stop method when I could just count up in 28s. 4 remainder 9, so that would be 4 and 9 28s. Okay. Area of the green shape. Okay, a little bit more complicated. So the green shape is the big rectangle, take away the little rectangle. So the area is going to be that. What's the formula for the area of a rectangle? Well, it's base times height. So we want to go 5 times 5x plus 3 for the big rectangle, and 3 times x minus 4 for the little rectangle. Okay, so let's expand and simplify. 25x plus 15. And then remember your times in this bracket, not just by 3, but by minus 3, because of the way we set it up. So I think, minus 3x, that's fine, but it means that our next term would be plus 12, because it's minus 3 times minus 4. Then simplify it all together. You'll notice this is generally the case with algebra. It's always expand and simplify. 22x from the 25 minus 3, and 27 from the 15 plus 12. And that's done. If we then said n is equal to something, we could have an equation to solve, but it just wants the area. Okay, and again, you've got an expand and simplify here. Okay, so 8x squared plus 3x, and then again, we're times it by minus 2x here. So this will be minus 2x squared plus 10x. Again, just be careful. Okay, then simplify it together. 8x squared minus 2x squared, that's 6x squared. 3x and 10x, that is 13x. Job done. Okay, and our last foundation question, foundation plus, is Polygon rules again. So again, think, do you know the 3 Polygon rules? What's the first one? The first one is that the interior plus the exterior add up to 180. Then we have a rule for the interior sum and the exterior sum. Exteriors always add up to 360. Interior sum is always sides take away 2 times 180. Anything that mentions a regular polygon, you should just be thinking, well, these are the 3 rules I need to use. It says it's got an exterior angle of 15, so how many sides does it have? And for this, we're going to use rule 3. If the exteriors add up to 360, then we can get how many sides there are by dividing by 15. And that will tell us there are 24 sides in this case. Okay. So onwards to higher, and this is your grade 6-7, this is where most of my sets should be aiming. Okay, what does the word rational mean? Rational means whole numbers, and it means fractions. So this question is asking which of these numbers are whole numbers or fractions. So you need to just work them out as much as you can. 4 to the power of 0, well, anything to the power of 0 is 1, so that is a whole number. Square root of 64, that's 8, that is a whole number. Square root of 3 doesn't have a nice square root, so that is not going to be a nice fraction. Pi, that's not a whole number or a fraction either, that goes on forever. And then remember 0.5, that's the same as a half, and anything to the power of a half means the square root of that number. So the square root of that is 10, and that is a whole number as well. So it's those three, but that's the reason why. Okay. Now this one is a graphical inequality, and it's all to do with drawing lines and trying to find the regions in between the lines. So what we need to do is essentially draw some lines and then decide which side we want to be on. So from this first inequality, we're going to draw the lines x equals -2 and x equals 1. From this one, we're going to draw y equals -1, and for this one, we're going to draw y equals x plus 1. So you can see that there's 4 lines that we need to draw. Let's do the first 3 because they're quite straightforward. Let's do them in different colours, why not? So the other thing you've got to bear in mind is whether your number's going to be, your line's going to be dotted or not, actually, and that depends on the sign. So if it is a less than sign or a greater than sign, we want dotted lines. So these 1, 2nd, and 4th one, they're all going to be dotted lines. This one, because it's got a or equal to in the symbol, that's going to be a flat line. Anyway, let's try drawing them. So our first one, x equals -2, dotted line, goes through where x equals -2. Let's properly colour code this one. Second one goes through x equals 1, dotted line again because it's just a less than symbol, and we'd have an x is equal to 1 line. Third one, y equals -1, but this time it is a full line because we've got an or equal to symbol there, and we just draw that through where x equals 1, where y equals 1 rather. And then our last one, we have to draw the line y equals x plus 1, and we want this to be dotted. Now again, if you weren't sure how to draw the line at y equals x plus 1, you could give yourself a little table to fill in. So we could come up with some x values, why not 0, 1, 2, add 1 to them, because that's what the rule says, 1, 2, 3, and there's some coordinates you could use. So we've got 0, 1, 1, 2, 2, 3. You could also think about it having a gradient of 1 and an intercept of 1, so it'd have to go through the y-axis at 1 and then go up 1 square every time. But either way, and that's a dotted line, as said. There we go. So here's all of our lines. Now, what do we need to do? We need to show the region which satisfies this. So that means we want something that is in between these two lines, that is above this line. So let's think about that. We want to be on this side and on this side. We want to be above the y is greater than, well, that says -1, that doesn't say 1. Whoops. Okay, yeah, that makes a bit more sense. Okay, so yeah, so we want to be above that line, and then we want to be below that line. So what are the things that are fitting that quality? It's this little triangle here. So show the region, we shade it in. That is the answer to our graphical inequality. That might be something you want to practice a little bit. Very good to look that one up on Corbett, etc. Okay. Then we've got another mean estimate. So what are the two things we need to add on if we're estimating a mean? We need to add on the midpoint, and we need to add on an fx column, and then we need to work them out. So remember, midpoint, obviously, you just find the middle of the values. And again, you can also find it by adding the start and the end together and dividing by 2. So I could find this as 175 by going 150 plus 200 and halve it. And then fx is obviously those things multiplied together. So we work all them out. We want to find out the total of the fx column and the total of the frequency column. And then to estimate our mean, we just need to divide one by the other. Average 150. Look at the values and think, is that roughly in the middle here? Well, the values start at 0 and end at 250, so yeah, somewhere in the middle of that. If you got like 300, you know you've gone wrong. Okay, and then finally, we've got what looks to be a scale factor question, because we don't have enough information to do much more than that. This is actually a volume. So it's like it's an amount of liquid, but as far as you're concerned, you treat it like a volume. And then remember, general rules for scale factors is that you square to get the area scale factor, and you cube to get the volume scale factor. So here we're probably going to cube to get our volume scale factor. Always want to start by finding your length scale factor. 15 over 10 is 1.5. Your volume scale factor is then 1.5 cubed, which is going to be some sort of unpleasant decimal, 3.375. I know to get the larger vase, we need to go 700, which is the smaller one, times 3.375. Which gives us 2,362.5 milliliters. Okay. So higher wasn't too bad this time. Maybe apart from the graphical inequalities, might be something to have a look over. Estimate of a mean, obviously, and scale factor. Ooh, a very, very similar question for higher plus. Okay, so roughly speaking, this is the same sort of deal. We want to find out the volume of the small pot, and then the volume, relative volume of the big pot, using these 30-litre bags. So let's start off the same way we just did. That is, we're going to find the length scale factor, which is 14 over 10 this time, 1.4. And let's find the volume scale factor, 1.4 cubed, 2.744. Okay, so we're going to use that in some way, like to get from here to here, volume-wise, you times by 2.744. What information do we actually have? We've got, with the first bag, we fill 20 small pots. Okay. Now each bag contains 30 litres, so if we divide that by 20 pots, we can get that a small pot is 1.5 litres. And litres, just like millilitres in the previous example, is a volume. So we can get, that was for the small. So for the big pot, we could take that 1.5 and we could multiply it by our volume scale factor. And we can get that a big pot is 4.116 litres. I'm not rounding anything here because I'm not sure exactly what it wants me to do with it yet. Okay, how many large pots can be filled completely using the second bag? Well, the second bag also contains 30, so all we have to do is 30 divided by our 4.116, and that would tell us 7.29 ... pots could be filled, but it says how many large pots can be filled completely, so just 7. Okay, so that actually wasn't too bad. Still length scale factor, still volume scale factor, and then we just need to use the extra information to work out the volume of the first pot rather than being told it. Okay, cool. Make M the subject. Ah, this is a Mechford, isn't it? Surely the best of all the rearrangings. So if any time it says rearrange, make M the subject, change the subject, any of that stuff, and you can't see any squares, it's going to be Mechford. So what are we first going to do? We're going to multiply our bracket across, our fraction across. That's our m. We're going to expand our brackets. ym plus 5y is m plus 4. We're going to collect our terms. Now it's m that we want to make the subject, so we need to collect all the m's on one side. So we'll do that by subtracting the m from the right and also subtracting the 5y from the left. Okay. F factorize. We want to take out a factor of m because we want m to be the subject. And then divide by the bracket that you just made. And there we go. Classic Mechford, 4-5 marks, grade 8. Lovely. Okay, and again, it's a similar question to what we had before. We've got this point lies on a circle with a centre. What's our equation for our circle? The equation for our circle is always x squared plus y squared is r squared. At GCSE, it goes a bit different in further and A level. And we don't actually have the equation this time. We've got a point that's on the circle. So what we're going to do is we're going to sub that point in here to work out what r squared is. So this is our x and this is our y. We can go 5 squared add 12 squared that's 169. And if we square root that, we'll get 13. So this is 13 squared. This tells you the radius of the circle is 13. And if we want the coordinates of another 3 points on the circle, we could just draw it out. It's got a radius of 13, so we could have the coordinate 13, 0. We could have the coordinate 0, 13. We could have the coordinate 0, minus 13. We could also have minus 13, 0 on the other side as well. There's another way around you could do this by just fiddling with the 5 and the 12, because you know that if you square them, it doesn't matter if they're positive or negative, so you could have like minus 5, 12, and 12, you could even have 12, 5 as well, that would work the same. So yeah, if you've got any combo of 12 and 5, that works as well. Okay, and then our final question. This shows a graph. It goes through these points to find the value of p. Okay, so it's similar to the one we just done, in that we have an equation, y equals ab to the x, and we've got some points. So the first thing we're going to do is substitute those points into the equation. So let's use 250 first. Remember, the first one's x, second one's y. First one will give us that 50 equals ab to the power of 2. Okay. If we sub in the second one, this will tell us that 6,250 equals ab to the power of 5, and then eventually we're going to have to work out the third one, but we don't know p. So this is actually a quadratic simultaneous. In fact, it's not even that. It is a simultaneous, but it's not even quadratic, it's quintic. And it looks really complicated, but there is a really neat trick you can do here. And I'm actually going to write out the first line again, because it feels a little bit nicer with what I'm going to do. Normally, you'd be looking to substitute things in, essentially. But we're actually going to do something a bit clever here. We're going to divide. We're going to divide the top line by the bottom line. So previously with simultaneous equations, we like added them together or subtracted. But you can do anything with two lines. This time we're going to divide. So on the left-hand side, 6,250 over 50. In fact, let's write this out properly. And on the right-hand side, AB5 over AB squared. So the left side simplifies to 125. The right side, what happens with that? A divided by A cancels out. B5 divided by B2, you subtract the powers, so it's B3. So we can get straight away that B cubed is 125, and we can cube root that to get that B equals 5. Okay? Then we could substitute that back in, say to the top line. We could say that 50 equals A times 5 squared, so that equals A times 25, and that tells you that A equals 2, because 2 times 25 is 50. Okay, so let's go back to the question. Calculate the value of p. So we know the equation is y equals 2 times 5 to the x. And the equation for p, so we know that x is minus 1, and p is the thing we're trying to figure out, is y. So p is 2 times 5 to the power of minus 1. And then if we stick that in, we can get that p is 0.4, or 2/5 if you prefer. It's quite a difficult question to finish off that one, but I quite like the other ones. It is a simultaneous equation, and obviously if you're given an equation, a line, a curve, and some points, then just sub them into there and see what happens. That's certainly what happened with our last 2 questions here. Classic Metford, bit of scale factor. Okay folks, hope that helped. I'll see you tomorrow. Cheers.